Hello, my name is Justin Maeder, and today I'm going to go over my peer grade assignment for human factors in AI. I'm carrying over the same problem statements and models that I've been doing the last few times in the course. So just to reiterate, within the identity realm, it is very important for a company to know if that user is in fact logged into the system themselves or if it's a malicious actor. This is just as important for the end user to ensure their identity and PII or personally identifiable information is never at risk. So doing a task analysis on this, we're going to start with the actual task at hand. The end user needs to check their financial records, whether it's just checking their balance, making a credit card payment, whatever it is, some type of application banking app is required for this. The trigger, a part of this end-to-end workflow, is in fact the end user receives an email that his or her payment is due. Typical, whether it's an email or notification, they receive some type of notification that it is due. The tool they're going to use is either a banking application that they may have installed on their mobile application or the banking or credit card website. So step one, the user logs into the system. Very typical. They log into the system. So the user logs in, whether it's the good user, the actual, in fact, the true user, or a bad actor with a specific identity factor, whether it's single factor or multi-factor, that they log into there. That's the first action. The second action is a specific task or multiple tasks are done. Each system, whether it's banking or credit card, has specific tasks that need to be accomplished. And usually there's an average time it takes to pay a bill or make a transaction, make a transfer to complete that specific task. And then last but not least, part of the workflow, the last task is the actual end user logs out of the system. They can either explicitly log out by clicking the sign out or log out button. They could close their browser or in fact close the app that's on their mobile device, the form factor. It all depends on which factor they're using. So there are a lot of decisions that are made here, and there are a lot of different inputs that machine learning and decisions that machine learning can in fact take advantage of. As far as the user experience design, the proposed solutions are around security. So of course, you don't want, it's good to have security in the forefront of the customer, but a lot of times, the end user, especially, figures and expects the security aspect to be covered behind the scenes. So a lot of the user experience will be invisible to the end user. However, we have still broken out into three different categories. The user inputs would be their logon location. Every single IP, every single hop in the chain has a location associated to it. The credentials, whether they're good or bad, there's some type of information happening. Actions, what's going on as far as the clicks from paying a bill, from transferring it, from editing the profile. There are many different actions that happen on an application or within the banking website itself. And then last but not least, some of the security prompts. And I'll kind of mention what this means in a little bit under transparency, but security prompts are, maybe it's multi-factor, maybe you are getting a prompt saying, is this you? Or if we jump into the transparency aspect, maybe a CAPTCHA form saying, hey, I haven't recognized this location as browser before. Do you want to trust it in future logins? Or maybe something as simple as, hey, just to ensure this is you, let me send you a OTP or one-digit PIN to your email or to your phone via text message or even call. There's a lot of things that happen behind the scenes, as well as right in the customer's face to ensure that that application or that website is taking the next steps and doing their due diligence to, in fact, be secure. When it comes to understanding detections or IOCs, indicators of compromise behind the scenes to, in fact, form that confidence, is this true of the user or is it malicious or a bad actor? Communicating uncertainties. Sometimes you'll get a suspicious activity email that gets sent over saying, hey, yes, you logged in successfully, but just, hey, was this you? If it wasn't you, then, then go reset your password. Maybe some other browser prompts above, as I explained in the past. Or again, once again, maybe a text message or phone call saying, hey, someone logged in with the credentials. Was this you? If not, call this number or change your password, reset credentials or whatnot. Check for anomalous activity and things like that, especially when it comes to your financial records. Some of the privacy concerns around this, doing the ML models behind the scenes to check for bad actors, malicious activity, or IOCs, is we're going to be gathering some PII data behind the scenes, such as the location, the IP address of where that last hop came from, whether that last hop was a proxy IP or a gateway IP, what was that last hop, the username, and of course, we already have the phone number, but we'll be making an explicit SMS gateway call outbound to that phone number as well. So there is some type of PII data concerns. Now, of course, banking websites they do service end users around the world. So if in fact these users reside or are visiting to GDPR or the IP address is coming from an EU region, GDPR does take into account, especially if the end user is traveling back and forth. We're going to need a way to say, hey, this end user is an EU. Have they consented already to the requirements and to the information we may or may not be gathering and utilizing behind the scenes? But there needs to be a way to have that concern as well. Now, last but not least, let's jump into some of the ethical concerns of our model that I've been working on the last 3 or 4 courses. Some of the biases around user traveling. The expectation would be that users are, local when they're checking their bank applications, but of course, users do travel, some end users more than others. So we have to take into that account. And also the form factor they're using. If we go and say, hey, all the users are expected to use the mobile app because that's what majority of the users do, and all of a sudden that user then goes start log in from web browser, whether from a dedicated device or a shared device, that could be biased as well. Some of the fairness, I couldn't really think of any, so I'm going to kind of skip that for now. The accountability, though, would be on the system owner, the backend system, the SecOps team, the ones that are creating the model, looking for IOCs, looking for that anomalies. And yet we can look for them, we can find them, we can alert them. But overall, the password complexity, the password being set, opting into multi-factor, all additional security measures are in fact the end user's responsibility when it comes down to it. Now, transparency, we can always provide like a last activity page to say, hey, this is the last 10 attempts, were these you, were they not? If they weren't you, then in fact, take the next steps, next actions to remediate that malicious activity, such as changing the password or resetting the OTP. And then again, providing a feedback loop back and forth, because in an ML model, we are providing confidence levels of, is this true of that user or not? There may be times, there may be anomalies where it is in fact the user, they're acting out of their norm. Again, user behavior, they're acting out of their norm. And we want to ensure that in fact was whether or not in fact it was a false positive or a false negative. We want to know that when it comes to abnormal behavior from the end user. So in all, this is my peer grade report. Thank you.